over what integral could you integrate to find the area of one leaf of the rose r equal 2 sine 3 theta? And it says could because remember that things are not unique in polar coordinates. Well, let's go ahead and make a sketch in rectangular coordinates of r and theta so we can see what our graph looks like here for our rose. And so we know the amplitude is 2 and the period is 2 pi over 3. So we're going to go 1, 2, 3, and the fourth one is going to be our period, which is 2 pi thirds. So that means this one is pi thirds and this one is pi sixths. As we put our graph on then at 0, it's 0. In the first fourth it's at its max, and then crossing, and then minimum, and then back to the intercept. So it's going to look like this, and that's around to 2 pi thirds. Now let's see how that looks in the polar world. So at 0 we're going to be 0. Let's go ahead and we'll make a couple of tick marks here around. Alright, so at 0 we're going to be 0, and then as we get to pi 6 we're going to be out to 2. So pi 6 is actually right here, and then here's pi thirds, and so we're going to be out 2, and then so we're going to come like this, and then from pi 6 to pi thirds we're going to go back to 0. So there's actually one leaf of our rose. If we continued here from pi thirds to pi halves, we would have negative 2. So as we would go up here to pi halves, we would go down here to negative 2, and you can see we're starting to build another one. So the interval so that we could get one leaf of this rose, and notice it says could, so but this would be an easy one, would be if we looked at theta between 0 and pi thirds. You can see that made our loop here. And this is what the graph looks like, and so you can see that we would get that from doing that. And of course we could have done one leaf by doing this one, or we could have done this one, or we could have done some other things that are more than 2 pi or negative angles, those kinds of things.